Let's discuss a question on engineering mechanics. This is basically collision of two bodies where the first body, which is of 2 kg mass, is, so we assume that this is the positive x direction. Okay, so 2 kg mass, this is moving with 5 meters per second. Then you have another 3 kg mass which is moving with in the negative direction with 2 meters per second. Now after the collision, the 2 kg mass moves towards the left with 1.6 meters per second, so it's minus 1.6 I, and 3 kg mass is something which we don't know the velocity. The coefficient of restitution between in the collision is asked. Now this is, now if we consider 2 kg mass, what is the external force? The external force is the collision force that is coming from 3 kg. And if you individually consider 3 kg mass, the collision force is again coming from 2 kg. But if you consider your system as m1 plus m2, I mean both together, if you consider your system, there is no external force. So no external force before or after the collision or during the collision. If you consider your system m1 plus m2, so no external force, linear momentum is conserved. Linear momentum is conserved. So linear momentum is conserved. So we write down momentum before linear momentum before impact, before collision, is equal to linear momentum after collision. So before collision, the linear momentum is m into v, so 2 into 5. So we assume this is the positive direction. So m1 v1 plus m2 v2 before the collision has to be equal to after the collision, m1 v1 plus m2 v2 after collision. So on the same lines, now 3 kg into mass into velocity is the momentum. So 3 into 2 is the momentum, but it's going, the velocity is towards left, so the momentum is towards left. So 3 into 2. So this is sum of the momentums at before collision. And after collision, 2 kg and the velocity is minus 1.6, so it's towards left. Now we assume that the 3 kg velocity is towards right, so 3 into v. So this is before the collision, this is after the collision, and let's find out. This is 10 minus 4 6, 10 minus 6 4, this is minus 3.2 plus 3v. So if I calculate, I get 7.2 on the left side by 3, it's 2.4 meters per second is the, so it's moving towards right. Now coefficient of restitution is nothing but magnitude of relative velocity. It's the ratio of magnitude of relative velocity after collision to before collision. I mean after collision by before collision, magnitude of relative velocity. So basically that's why we are writing mod. So irrespective of the sign, what is the relative velocity? So relative velocity, if you look, this we got 2.4 is towards right and 1.6 is towards left. So they add, so 2.4 plus 1.6 mod, and here it's 5 towards right. So relative velocity, so 5 is like this, 2 is like this, so the relative will be 7 in this direction, or if you want to write in this direction also, it's 2 minus of minus 7, so it's 7 in this direction. Either way, wherever you see, so 5 plus 2 7, so it's 4 by 7, it's 0.57. okay, so this is the coefficient of restitution, 0.57. So this is an easy problem. Just apply the momentum. Momentum is always conserved in any kind of collision, and depending on the restitution, whether energy is conserved or not. So if restitution is 1, it means elastic collision, energy is conserved. If restitution is 0, it's plastic collision, energy is not conserved. 0.57 is the answer. Thank you.